A very good morning to all the dignitaries, respected professors, ladies and gentlemen. At the outset, I, Purvak Singh, and my friend Siddharth Kumar Singh express a warm and respectful welcome to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science, and Engineering, organized by the Department of Computer Science and Engineering, MIT School for Engineering and Technology, MIT University, Uttar Pradesh, Noida. As one of the leading global universities, MIT University is dedicated towards its responsibility of imparting its students with strong foundation and a platform for the empirical inquisition. With this agenda, Conference 2024 intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of new generation technologies.
May I invite Dr. Neha Tyagi ma'am, Associate Professor from MIT University, Noida, UP, to present a sapling to our esteemed speaker, Dr. Suresh Vishwakarma, Senior Engineer and Adjuncted Professor from the University of Trinidad and Tobago, Canada.
Yes, sir. I welcome you here in Conference 2024. Here is a Tulsi sapling for you. Welcome.
Thank you very much. When I come in person next time, I will collect that.
Yeah, sure, sir, sure. Okay.
You owe me 3 now because this is the third event.
Yeah. Okay, sir. We will give. Okay.
It is our great privilege and honor to have Dr. Suresh Vishwakarma amongst us. Professor Dr. Suresh Vishwakarma, a professional engineer in BC Province, Canada, and engineer of Engineering Council of UK. He is working in the utility industry since 1988, holding engineering and managerial positions. He has undertaken postdoctoral research in energy conservation at the University of West Indies. He has extensive experience in the generation, transmission, distribution, asset management, and human resource development in utility companies. His key areas of strength include the capability to take on challenges, exceptional human relations, innovation, responsibility, self motivation, and flexibility. He is also a very result oriented team player and team builder. He is an honorary professor at Amity International University. He was an adjunct professor, utilities engineering at the University of Trinidad and Tobago for 1 year. He is also an external evaluator at the Acceleration Council of Trinidad and Tobago. He is an active member of Institution of Engineering and Technology, UK, and Engineers and Geoscientists of BC, Canada. His areas of expertise include asset management, power distribution, energy access, renewable energy, energy efficiency, efficiency policy, and energy conservation. Now, I request Dr. Suresh Vishwakarma sir to kindly address the gathering with his words of wisdom. Please, sir.
Thank you very much, gentlemen, for the nice introduction. I am now sharing my screen. But I think I'm not allowed to share the screen because somebody else is sharing. You need to, you need to close. You need to stop sharing at your end. Can you see my screen?
Yes, sir.
All right, okay, but I cannot see anyone now. My screen doesn't display anything else apart from my own presentation. So if you have any question, any such thing, you just need to voice your concern or voice your question. So greetings to you all, ladies and gentlemen, all present, my dear fellow keynote speakers, scholars, guests, and everyone. A very good morning to you. Of course, at my place it is 8 p.m. in the evening. I'm still Wednesday. We still have Wednesday here, full of snow. Everyone, before I start my presentation, I forward my felicitation for the success of the 14th International Conference. Still, you are able to see me?
Yes, sir.
Can you hear me? Can you see my screen?
Yes,
Everything is okay now,
yes, sir, everything okay.
so that we don't waste time again. All right, okay. Once again, greetings from Vancouver to everyone. Thank you very much. Before I start my presentation, I forward my felicitation for the success of the 14th International Conference Confluence 2024 and greetings to Dr. Atul Chauhan, Chancellor of Amity University, Dr. Ashok Chauhan, Vice Chancellor Dr. Balvinder Shukla, Professor Manoj Kumar Pandey, Professor Sanjeev Thakur, Dr. Garima Agarwal, and Dr. Neha Tyagi. Thank you very much for inviting me to this mega event Confluence 2024 as a keynote speaker. I remember contributing to 3 events of Amity last year. Probably I might get some few more chances to contribute to Amity this year also. Are you able to see me? Are you able to hear me?
Yes, sir, everything fine.
All right. Okay, this gentleman already spoke about me, introduced me. This is a small, brief profile of mine, highlighting my academic and professional journey. I'm not going to read everything because my time has been reduced. I had the privilege of presenting the findings of my postdoctoral research work in January 2023. The photo, you can see the lady on the extreme left, she is standing next to me. She is the Minister for Planning and Development of Government of Trinidad and Tobago. I presented my work to her. And then I also my co-researcher, Dr. Ruchi Tyagi from University of Petroleum and Energy Studies, she was the co-researcher at my postdoctoral study. She also presented online while I was in Trinidad and Tobago. This gentleman mentioned that I am associated with IET. Yes, I am very active. I am an active IET member. I often organize student competition. You can see the image below where students participated and I was the one who coordinated the event. There are few publications also I have pasted here. Are you still able to hear me?
Yes, sir.
Everything is okay? All right. These are my recent presentation. Last year I made 2 presentations in Canada. I was also invited by IIT Indore to present almost the same topic to their research scholars. This is the outline of my presentation. I am initiating a talk on the connection between sustainability and sustainable systems. Before jumping to sustainable electronic system, I will also touch upon green technologies. I will also share some thoughts on the practices and strategies to make electronics engineering more sustainable. Highlighting the impacts of ongoing climate change, I would also mention the expectation of future engineers like you. Ladies and gentlemen, nowadays we very often hear about sustainability and sustainable systems. But Garima and Neha both mentioned to me that it would not be an interactive session today. Otherwise, I would have appreciated the thoughts of tomorrow's engineers present here today. I can see a number of students.
Sorry, sir.
As you can see, sir, yes, can you hear me?
We will have your guest lecture with the students in the future on this.
Not a problem.
Yeah.
You have already reduced my time by 50%, but it's okay
Sorry.
now.
Sorry, sir.
All right. Okay. So sustainability, as it is mentioned here, it is a societal goal with 3 pillars: the environment, economy, and social dimension. And it is the responsibility of each of us, everyone on this planet has a responsibility towards sustainability. Actually, it means that we must never compromise the ability of future generation to meet their own needs. In addition to the environment, sustainability also concerns social equity and economic development. When we talk about sustainable system, as you can see, it has been defined differently in dictionaries by academia and the professional bodies. But the bottom line is the environment and society must never be endangered by human acts. Sustainable systems and sustainability offer long term benefit from ecological, economic, political, and cultural dimensions. Here are the 17 sustainability development goals of United Nations to transform our world. I'm not going to read everything, but ladies and gentlemen, engineers of tomorrow and engineers of today, we can play a crucial role in achieving these sustainability development goals. Developing affordable and reliable technologies that are more accessible to people worldwide, revolutionize, revolutionizing agriculture and food production with mechanization, fertilizers, and pesticides, people's life with medical devices, as it happened during the time of Corona, using robotics, computer vision, and artificial intelligence to drive advances in health, creating new gentlemen, I think there is some problem at your end because I have got very high bandwidth connection. This is the third time we are breaking. All right, okay, let us continue. Can you see?
Yes, sir.
All right. So as I was mentioning, that engineers they can play a critical role and crucial role to undertake these sustainability development goals. These goals were adopted by United Nations in 2015. These are actually a to-do list for people and planet and a blueprint for success. I would would like to have opinion of you all, but I know it is not possible. That what are sustainable practices and what are sustainable strategies? As you can see here, the sustainable practices they and sustainable strategies they go hand in hand. Sustainable practices support ecological, human, and economic health and vitality. In simplest terms, sustainable practice is to ensure to care about our children, our grandchildren, and the world we live for them. On the other hand, sustainable strategies they incorporate economic, environmental, and social factors into organizations' policies and practices and processes to create a long-term benefit for organization as well as its employee. But at the same time, we have to be very much mindful of conserving and protecting our resources. Ladies and gentlemen, there is another term going on these days, green technologies. What is that? Any technology that does not injure or impact the Earth's environment through supply, manufacturing, use, and disposal. That is green technology. For a sustainable future, electronics technology and equipment need to ensure a more effective use of our resources as well as causing minimum pollution and use of resources as possible. Ladies and gentlemen, now let us come to your own world. I know that majority of the students are from electronics engineering. What are the sustainable consideration in electronics? The five key principles to design environmentally sustainable electronics include chemical management, energy efficiency, material management, design for recycling, and expandability. Ladies and gentlemen, I would like to mention here that in Canada specifically and in the electronics industry generally, customers and the users they are increasingly conscious about the importance of supporting sustainability. So they first consider that this manufacturer, how sustainable is the practices at this organization, then they go and they prefer their products. Manufacturers, therefore, they need to invest in creating sustainable material and products across their production cycle. Manufacturers, they have eliminated environmentally sustainable sensitive chemicals, redesigned packaging by including recycled and recyclable material, and created programs to recycle electronics responsibility. These are something, a few of them which I am listing out due to shortage of time. Otherwise, I would have quoted the example of few industries here. There is another thing. It would have been a very good question. What is the difference between energy conservation and energy efficiency? Can you still hear me or I am still broken?
We can hear you, sir.
We can, all right. Okay. Ladies and gentlemen, energy conservation actually it involves using less energy by adjusting our behaviors and habits. So it is actually a behavioral issue, energy conservation. It is the decision and practice of using less energy. Whereas on the other side, energy efficiency, it involves using technology, those technology that require less energy to perform the same function without compromising the comfort level of the user. Due to shortage of time, I cannot read a lot of things. Now, are there practices and strategies to make electronics engineering more sustainable? This is actually your baby. But this never happened before. So many times I have given online, conducted online session for Amity. Such problem never came up before.
We are sorry for the inconvenience, sir.
Or no, inconvenience is for you.
It's okay, sir. Sir,
So I was
in the next 5 minutes, you can conclude the topic.
So these are the key practices and strategies to make electronics engineering more sustainable. The design for sustainability, energy efficiency, material selection, recycling and e-waste management, circuit optimization, renewable energy transition, life cycle analysis, efficient manufacturing processes, software optimization, collaboration and standards, consumer education, research and innovation, government policies and regulations. These all need to be considered. Unfortunately, due to shortage of time, I cannot discuss. This was actually something I was trying to discuss, and I wanted to share my opinion, and at the same time I was thinking of inviting your feedback also, but due to shortage of time this could not be done. These are few examples of sustainable practices and sustainable strategies. I have quoted the example of Siemens and Hitachi. Their design, it their manufacturing process reduces carbon footprint of gripper solutions. They also decentralize their production and optimize factory planning using digital twins, using to reduce carbon CO2 emission. They have got 3D printing and biodegradable material that reduces pollution. Likewise, when I talk about strategy, Hitachi's environmental vision as one of the pillar of their organizational sustainable strategy. What they have said that Hitachi will resolve environmental issues and achieve both a higher quality of life and sustainable society through its social innovation business in collaborative creation with its stakeholder. Here, it's an example of a technical research center of Finland. They also provide design solutions, electronic design solutions. Their areas of expertise, actually they focus on additive manufacturing process, which is low emissions and low losses. They have got new functionalities through the use of bio-based, renewable and abundant mate. They navigate the regulatory landscape and carry out sustainable assessment for each of their process. Their chart is shown on the right hand side that their each product is eco designed. They use sustainable usage and disposal. They use sustainable material, and they practice energy and resource efficient processes. Even in India, I know now there is a e-waste management rule, government of India, and whereby all manufacturers, they are expected to collect their e-waste generated during the manufacture of any electrical and electronic equipment and ensure its recycle or disposal. Even bulk consumers of electrical and electronics equipment, they are expected to ensure that e-waste generated by them shall be handed over only to the registered producer, refurbisher or recycler. Again, I'm not going to read everything, but I know that things are moving in India also. Ladies and gentlemen, these days, climate change is creating havoc around the world. Even today, also, we had 2 feet, which is 24 inches of snowfall. My backyard is full of snow. In fact, I shared the pictures with Neha. She can onward share with you. That was the situation on the backside in my backyard. So situation is really very alarming. There is high uncertainty of extreme weather and natural disasters. Weather related event, they not. So I was mentioning about the weather related extremities, which include heat waves, wildfire, freezes, tornado, floods, tropical cyclones, and these climate related extremities, they are persisting now longer than weather events. Something happens, but the consequences, they keep on dragging for another few days. So ladies and gentlemen, especially the students, this is something this is the gist of my presentation, that these are the expectation from future electrical and electronics engineers. I'm not going to read everything, but you just list out. I have listed out that meeting varied industrial challenges, you need to have sustainable practices. You are expected to have innovative approaches. You are expected to give due regard to health, safety, and environment. And must ensure that after passing out from university, you should always follow continuous learning and development. Your communication skills must be Excellent. Engineers should be engaged for preparing and presenting clear justification to implement more sustainable solutions that serve the public interest. The final note is throughout this 21st century, electronics and electrical engineers will play a big role in the future in electrifying every system that traditionally dependent on burning fossil fuel. So trust me, this branch is very highly contributive to society. You can contribute a lot to the community and society and to the planet as whole. This being an electronic engineer. And sustainable development is one of the key requirements for electronics design these days. So, younger generation, young boys, ladies and gentlemen, focus. The electronic engineers, this electronic engineering needs to lead a designing technology for the green transition. I would have loved to talk to you more, but three times we have broken. I don't know if you are still able to hear me, if you are still able to see me. If you have any question, these are the references I had taken. If you have any question, and I don't know if you still have time, I will be happy. I don't know how much time you are left with. Mm, is there any question? Or I am sorry for all this technical glitch.
Any questions from student side? No? Okay. Thank you, sir.
My pleasure. I would have really loved to talk more, but we broke few times.
Thank you, sir. With this, we conclude the session. We hope that it was an enriching and information experience. I once again, on the behalf of fraternity of MIT University, Uttar Pradesh, Noida, thank all the guests and dignitaries for their significant presence. I would also like to thank all the students for cooperating with us. Thank you. Thank you.
I can share my PowerPoint with Garima. Maybe if somebody is interested, okay, you can share onward.
Yeah. Okay, sir. Thank you, sir.
All right. Thank you very much. So you all have a nice day and enjoy the rest of the conference. And maybe after a few minutes, I'm going to go to sleep. It is late evening here. Thank you very much. Nice meeting you.
Okay, nice to meet you, sir. Thank you, sir. Thank
Bye
you.
bye. Bye.
So, very good morning to all the distinguished dignitaries, respected professors, ladies and gentlemen. At the outset, I, Rishabh Goel and Vertika, express a warm and respectful welcome to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science and Engineering, organized by Department of Computer Science and Engineering, MIT School of Engineering and Technology, MIT University, Uttar Pradesh, Noida. As one of the leading global Amity University is dedicated towards its responsibility of imparting its students with strong foundation and a platform for empirical inquisition. With this agenda, Confluence 2024 intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of next generation technology. May I invite Dr. Neha Tyagi ma'am, Associate Professor from AMT University, Noida, UP to represent a sapling to our esteemed speaker, Dr. Banani Roy, University of Saskatchewan, Canada, on supporting multidisciplinary data analytics. It is our great privilege and honor to have Dr. Banani Roy amongst us.
Yes, welcome, ma'am, in Conference 2024. Am I audible?
Yes, I can hear you.
Okay, okay. Welcome, ma'am, in Conference 2024. I am presenting Tulsi sapling for you.
Thank you
It is our great
for having me. It's my pleasure to be here. Yeah, can you see me and can you hear me okay?
Yeah. Your voice is audible. Yeah.
Oh, okay, great.
So it is a great privilege and honor to have Dr. Banani Roy amongst us.
Professor Banani Roy is Assistant Professor and Director of Interactive Software Engineering and Analytics Lab at the Department of Computer Science, University of San Juan. She is a co-applicant of the NSERC CREATE program on software analytics. and has been involved with two Canada First Research Excellence Fund projects where she has been conducting research on human-centric software development and renovation, including supporting multidisciplinary data analytics and software analytics towards building human-centric tools and techniques for reliable, scalable, sustainable, and cost-efficient software development, maintenance, and evolution. With these projects, she has worked or has been working with over 20 graduate and undergraduate students with high quality publications and research awards such as Best Paper Award and Best Poster Awards, along with her students also winning Research Excellence Award, GETS Award, 75th Anniversary Scholarships, and so on. She is often involved in conference organization, most recently as program co-chair of SCAN 2022 and general chair IWSC 2023. She received her PhD from Queen's University, Canada, in the area of interactive software engineering. Now I request Dr. Benoni Roy, ma'am, kindly address the gathering with her words of wisdom. Ma'am.
Hello. Hi, thank you for the nice introduction. It's my true pleasure to talk about my research in front of you all. And I would like to thanks to the organizing committee for creating the opportunity for me. Special thanks to Professor Gorima, and I feel that she has been working constantly to create this opportunity, and thank you to rest of you. Yeah. Okay, hello everyone. You can see the title of my talk. It is supporting multidisciplinary data analytics. With this talk, I'm going to talk about the cloud-based platforms that we have developed to support scientists for analyzing different kinds of data with heterogeneous tools. I got already introduced, but still you can see my bio here. I did my PhD from Queen's University, Canada. Now I am the assistant professor at the University of Saskatchewan. It is in central Canada, and the winter is cold now. But we actually enjoy cold. And I'm also the director of Interactive Software Engineering Lab. I work with many graduate students and also undergrad students for my research. And I have been involved with two Canadian research excellence projects, which are P2IRC, plant-based image, plant-based image processing that can be used for plant phenotyping and genotyping. And another project is Global Water Future, which actually model water quality in Canada. And I'm also the co-applicant of SOAR NSERC CREATE grant for software analytics research. And my research interests include engineering scientific workflow management systems and software and big data analytics. Here you can see me with some of my graduate students. So here is my talk outline. In the first part of my talk, I will introduce scientific workflow management systems that have been used as multidisciplinary data analytics platform for supporting data-intensive scientific research. Then I will talk about SciWorks, a collaborative scientific workflow management system that we have developed in our lab. With SciWorks, I will discuss how we supported collaborative data analysis in different domains. After that, I will talk about vSciFlow, a visually guided domain language supported scientific workflow management system that we have developed in our lab as well. With VSciFlow, I will talk about how we have supported scientists to specify their data analysis steps easily. In the second part of my talk, I will give an overview of my software analytics research for handling software data. And finally, I will conclude my research with some future research direction. So, current research shows that traditional software systems are not suitable for big data analysis. So in this slide, you can see that in 2016, a group of researchers from Australia actually figured out that Microsoft Excel can produce gene errors. And they have scanned like more than 3,500 papers, and 1/5 of the papers contain gene errors created by Excel. For example, gene symbol like Sept2 was renamed as September 2. And this kind of error is severe in genomic analysis and raised questions about the research finding. So from this example, we can see that different kinds of platforms are necessary for big data analysis. And by realizing these requirements, a large number of scientific workflow management systems have been emerging, which include Galaxy, Cyverse, Kepler, Traverna, SnakeMake, and there are more. There are hundreds of scientific workflow management systems exist, and these data analytics platform provide analysis environment and workflows with reproducibility. These platforms basically support workflow lifecycle, which include composition, execution, and analysis of workflows, and management management of provenance data for diverse use of workflows. And it also offers error monitoring and tracking. Those who don't know about workflow, a workflow basically models a scientific analysis process. It divides the process into a number of steps, as you can see from this figure. In each step, a software tool or a module or a application is used to do the task associated with the step. And a workflow is always attached with an input source. When a workflow is executed in each step, the data is transformed into a different representation, and process data is generated. And this process data in one step becomes the input of another step. After the execution, a workflow always, you can see here, produces output that actually provides some important insights about the data. Okay, so in this slide, I added little bit more about workflow, about the properties of scientific workflow. So workflow is a structured entity, if you model it, that maintains strict data flow relationship among software tools, modules, or applications. And it connects software tools or modules or application written in different programming languages. So this is the beauty of scientific workflow management system, where you can actually make the data flow connection among the tools or software applications that are written in different programming languages. And it forms a directed acyclic graph. And the workflow, the created workflow is reusable by connecting with different data sources. And in scientific workflow management system, you can execute workflows many times as per the requirement. And when you are executing workflow, a large amount of intermediate data or process data is produced, and this process data needs to be maintained so that you can reuse these process data across different workflows to optimize the system's performance. So here I also show a diagram where you can see two modules are connected, and each module is configured with input, like it has an ID, then input, output. You can configure a module with different parameters. Then you need to specify the source source code for for the module, and then you can also specify the status of the module, like whether it is running or it is paused, those kind of thing. So that's how you can model workflow in scientific workflow management system. Okay. A workflow can be composed using graphical languages. So as I was saying, Galaxy is one of the popular scientific workflow management system for analyzing bioinformatic data. And here you see that a software tool is represented with a box, and the data flow connection between two modules or tools are depicted using this line. In the system, you see all the tools can be seen here, and you can drag and drop the tools here, and you can make the connection to make a workflow. So this platform used for bioinformatic data analysis. However, workflow can be composed using textual language as well. For example, XML, Python, JSON, or YAML could be used to write a workflow or compose a workflow. And you see here, I showed an example workflow from the system SnakeMake. Okay. As you can see, like nowadays, the today data analysis is complex, and a team of researchers need to work on joint research problem or joint research questions for scientific discovery. So collaboration is important in scientific research. So here I put two examples, like a large synoptic survey telescope, LSST, involved 1,800 scientists and engineers for a complete analysis process. Also, a lot of collaboration was happened for this scientific experiment, and it required like teamwork. And there is platform called My Experiment, and this platform actually offers a lot of collaboration opportunities. Like here I showed like around close to 4,000 scientific workflows have been shared among like more than 10,000 members. So here a lot of collaboration is happening by sharing workflows among large number of scientists. So collaboration is paramount nowadays in scientific research, and scientific like this collaboration is also realized in a scientific workflow management system in different forms. For example, some platforms including Galaxy support collaboration by sharing a single version of workflow. Confucius, another scientific workflow management system, it supports real-time synchronous collaboration where a group of researchers situated in different geographical location can compose workflows in a shared workspace. Sometimes what happens, collaboration is also important in asynchronous settings where collaborators need to work on different versions of the workflow, like we do in like GitHub for source code for source code sharing. Same thing happens in workflows, and the scientists work on a different version of workflows, then they merge it to a master branch. So one of the workflow is ProbDB that supports asynchronous collaboration. Okay, so as you can see, different scientific workflow management system exists for supporting scientific data analysis. However, there are shortcomings in the existing approaches. So in our one of our paper, like published in International Conference on Software Architecture, we figured out that by reviewing different scientific workflow management system that they lack in usability, as these frameworks don't consider user requirements when the workflow actually gets really complex, that involves a large number of software tools. Also, these existing systems don't support collaboration for large data analysis, and also they lack a high performance support for high throughput processing of massive amounts of heterogeneous data. So here I give an example, like iPlan is one of the scientific workflow management system. Now it is called Cyberse. So in iPlan BISC, a seed analysis takes 5 minutes for like 102 megabyte size of images. But when you involve image analysis for real world system, like it involves terabyte of data. So here I give that example, like you collect data using drones, and from the data, like it's in size terabytes. So you need to develop orthomesic image, then you need to do a lot of image processing like stitching, segmentation for feature extraction, and it involves some large size data. And this kind of workflow actually cannot be supported using the existing systems. So there is a huge gap in performance support with the existing system. So to overcome some of the problems in the existing scientific workflow management system, we developed Cyworks. With this, you can see the research prototype of this system. So what we have done, where so like several collaborators can join in this in a session in real time, and they can compose workflows by using different tools, and they can come from different expertise, and a workflow can be composed using the domain experts of the available tools. And here you can see they can drag and drop tools, and they can configure the tools, and they can make the connection, and they can make the analysis pipeline and run this pipeline, and they can also visualize the output of the workflow, like image, they can do it. And we also supported different CSCW technologies like telepointers. So if one work on the workflow, other can see that someone else is working. So it kind of provide the group or awareness that other collaborator is working, and they also could do use chat messaging. Okay. And there are different research challenges or questions that we have addressed using by developing Cyworks. It is also a cloud-based framework. So the first research question we addressed, how to support large scale scientific data analysis. And to answer this question, we actually investigated the existing scientific workflow management system like Galaxy, Cyverse, GenUp, and Lemnatech, and we investigated actually what are the big data technologies are out there, and how the existing scientific workflow management system are adopting big data technology. And after analyzing the existing platforms, we actually proposed a reference architecture that could be used to support large-scale scientific data analysis. Then in the research question 2, as we tried to support real-time collaboration while composing workflow, our research question 2 was how to maintain consistency and high responsiveness while editing a workflow collaboratively. So with this research question, we actually investigated different locking system, and we proposed a new locking system so that real-time collaboration could be supported with high responsiveness. Then the third research question was how to design real-world synchronous collaborative scientific workflow management system. So in order to design real-world collaborating system, what we do, we try to figure out what are the roles involved in a collaboration, and then we figured out the roles and how the roles are interact and what kind of task they could do. And finally, we proposed a architecture that can support actually collaboration in scientific workflow management system. And you can see all the works are published in a very prestigious venue. And if you are interested, you can take a look at the papers to know more about this work. Then the fourth research question we addressed, how to support different domains of scientific analysis. So we developed the framework. Then we needed to show that this framework is suitable for different kinds of data analysis. So it's not only suitable for bioinformatics data. So our target was to handle multidisciplinary data. So we worked with software data, we worked with bioinformatics data, and we also worked with image data to show that the platform we developed, Cyverse, is suitable for different domains. Then in our fifth research question, we worked on how to optimize the reuse of intermediate data for high performance of the system. So when you are using workflow, and you can use the similar workflow with the same data set, little bit of like the change in the tools, but when you are executing workflow, a lot of process data or intermediate data is generated. So for the system, it's always good if you could reuse the intermediate data in different workflows. So we come up with an algorithm using association rule to reuse intermediate data, and we also developed an interface how like scientists can choose intermediate data according to their requirement. And we also actually looked at how to support asynchronous collaboration in scientific workflow management system, because we figured out that the ProbDB that support asynchronous collaboration, it's not actually talk about a real world problem. It is only for the toy application. So we wanted to scale our work for a large collaborative system, and we used provenance data to support asynchronous collaboration and come up with a merging algorithm. Okay, now I'm gonna talk a little bit more on the research question for how to support different domains of scientific analysis due to the interest of time, I won't be able to go through all the research questions. So to answer research question 5, what we did, we created workflow using SciWorks in various domains. We explored bioinformatics domain first because of our involvement in an image-based plant phenotyping and genotyping project. As I was saying at the beginning, that I was involved with the P2IRC project, and where I worked with a team of soil scientists to support their genomic analysis. We learned about DNA sequence alignment workflow from them. Then we integrated different tools such as FastQC, Peer, and you can see here SAM2, BAM, all these tools to implement the workflow. With this workflow, what a scientist can do, the scientist can compare a candidate genome with a reference genome to discover new variant of virus and bacteria in the soil. So you have a reference genome, and when you have a candidate genome, you need this workflow to figure out whether it's a new variant or not. And after implementing this, so the soil scientists or our clients, so we implemented this, and they were happy with this workflow. Later, what we did, we actually went to my experiment, the repository where scientists share their workflows. So we collected some of the complex workflows from there, and we implemented these like here I named some of the workflows. As you can see, implemented the Galaxy workflows on SciWorks platform to see whether SciWorks is ready to work with complex workflows. And we also did a small scale user study involving 10 graduate students to see whether SciWorks is capable of supporting different workflow operations, and at the same time, it can offer CSCW technology, like the collaborative technology to when composing workflows. So what we did, we give these workflows, Galaxy workflows, to the users, and we divided we splitted the students in 5 groups, and we conducted the session in conducted the experiment, like user study, in 2 sessions, and we asked them to compose the workflows, and the workflow operations include like addition of module, addition of data link like data flow, and removal or update. And we keep track that how many operations they're doing. And at the same time, we allowed them for collaboration, like communication messages and like chat messages. So we observed those, and we have seen that actually the collaborators make use of the CCW technology, and at the same time, they are able to compose the workflows. Okay, then after exploring the bioinformatic workflow, what we did, we wanted to work with software data. And in order to use software data, actually, we have leveraged a software analysis tool called NICAD clone detection system. So as you know, clones, like software clones or code clones, are similar fragments of code in software by some definition. And this code developer, cloning is a very frequent things that developers do to increase their productivities, but clones and has side effects, like it can cause or propagate bugs in software system. So how clone is generated? So over the life cycle of a software system, code fragments could go many editing changes such as identifier name changes, addition, modification, or removal of statements. And over the time, the source code changed, and it becomes really difficult to figure out that whether that code fragment is clone or not. So we need some kind of similarity, similar like whether two fragments are similar or not. So we cannot just do the string matching. And in order to identify these uh, two similar fragments, the source code need to be actually transformed. So here I showed the workflow. So different transformation can be applied, like you need to actually rename the identifier, you need to do some kind of normalization for literals. So different steps are involved. Then you need to compare two fragments, then you need to do reporting. So here you can see it's a workflow. And we want, and NICAD is a tool that can actually do co-clone detection. And we wanted to leverage the NICAD modular architecture, and we implemented the steps in SciWorks, and we wanted to see whether this workflow could detect clone or not. And our experiment shows that it is possible to implement NICAD workflow in SciWorks. And similarly, we also implemented other clone detection tools that exist out there, like Sourcer, CC Finder. So we detected it, and we also, to validate the output, we developed a machine learning based model called clone cognition. And we also implemented the clone cognition workflow on top of SciWorks. And we actually was able to show that it is possible also to validate clone detection tools output using SciWorks. So clone cognition, the tool we have developed, and it is published in different conferences like SCAM, FSC, and in a journal paper. So I will encourage all of you to look at those papers.
Excuse me, ma'am. Am I audible?
Yeah. Yeah.
How many slides are left from your side?
I think 5 more.
5 more. Okay. No issues. Thank you.
Okay. Yeah, so I'm done talking with SciWorks, but now I'll little bit talk about vSciFlow, a domain-specific language-supported scientific workflow management system. So the thing is that with SciWorks, we represented workflow graphically, but and here we have shown also workflow from Galaxy. So what's the problem with the graphical workflow is that when it involves a lot of computational steps, the analysis actually very complex, and it needs to be applied with kind of multiple data set, and using the visual language, it becomes really cluttered and complex and confusing, as you can see. But at the same time, like textual workflows are easy for rapid prototyping, and you can change it, and you can actually make it reusable for different input source. Here you can see you can use for loop and all those things. But the problem with the textual language is that scientists don't like this programming language, and scientists get scared with this programming logic. Our user study shows that. So we wanted to make something in between. So what we did, we developed the platform called vSciFlow, where like it can actually generate some workflow code automatically. So scientists get access to the tool, they can drag and drop the tools, and the system can automatically generate the code that is necessary for this tool. And then when a first prototype of the workflow is generated, then scientists can do little bit of addition to make it more complex, like supporting with for loop, and all those things can be done. So this is our vSci flow that supports script-based workflow, but with visual guidance. And we also did a user study. So in our user study, we involved vSci flow, Galaxy, and Python. And here we also involved 10 graduate students, and we gave them 3 tasks which are incrementally complex, and we asked them to compose workflows. And as you can see, like in terms of usability, efficiency, and expressiveness, vSci flow actually performed really well. And some of the cases, what happened, even though we taught the graduate students Python, then how to use tools that are written in different programming language, like they were not able to form the workflows, they were not able to form the connection between the tools. So it's really important to use these high-level scientific workflow management systems for composing workflows, but we need some user-friendly system. And in this way, we try to overcome the usability problem in scientific workflow management systems. Okay, and another thing we did with vSci flow, like with vSci flow, what happens, you need the data source, right? And that data could be available in other system, and we developed a plugin. Using the plugin, you can easily bring data to vSci flow. And we have our SciData Manager, where we store data from different stakeholders, from different researchers. And like when you access vSci flow, you should be able to see the data that are stored in SciData Manager without any effort. But if you want to connect it with another database management system, so you should be able to do it using plugin, but some configuration is needed. Okay, here is the data analytics, some research summary that I talked about. So we have developed SciWorks for supporting collaborative data analysis in multidisciplinary research setting. And vSci flow, it's a usable, we actually created a usable interface and language for modeling and composing workflows. Okay, so now I don't have that much time. I'll just give a short overview what we do, what we are doing for software analytics research. So here, as you know, in the software development life cycle, which involves like design, then requirement design, coding, testing, and the deployment, then in all the phases, software produces lot of data. So it produces commit messages, pull request titles, it has source code, when you release data, you have bug reports, and when you need programming help, you need to use a Stack Overflow, where you can also get data. So for actually quality software development, what we need to analyze this vast amount of data, and we need to figure out important insights from the data. And we are conducting different research projects, like we are developing machine learning models, or we are applying natural language processing techniques to get the insights from this software data, and we are applying analytics. And we are also using our platform like SciWorks and vSci flow for this analysis. So here I will just give one quick example. Like when you are working with like software development, you need release note. And release note, what release note does, it actually captures the changes that happens in a particular release. And we have analyzed like GitHub projects, and we have figured out that for many releases, GitHub doesn't come with release notes, and which is problematic to understand a source code change. And what we are doing, we are actually using commit messages and pull request titles to generate release note automatically by applying different natural language processing technique like TF-IDF, GloVe, like text rank algorithm. And we are applying machine learning algorithm to generate like headings for the release note. So this is just an example, but I can share the slide with the conference organization. You can go through all the papers that we have published, and it will give you a lot of insights on how to apply analytics on software data. Okay. So in future research, what I am now working on, because we are working with several machine learning models, deep learning models, but these models are sometimes hard to understand. So we are applying trustworthy analytics to interpret the model output. So different techniques available to interpret the model output. For example, Lime, Shape, these are the tools exists now. And we are, but these tools or techniques don't offer consistent output. They disagree. And we are working on how we can make use of this technique by offering usable output from these tools. So we are working on trustworthy analytics. And for like scientific workflow management systems, like you need to work with complex workflows, and it involves a lot of tools, but sometimes it's really difficult for the scientists to remember all the tools. So if when you are composing workflow, we need recommendation system that can recommend a particular tool or a particular data set that you could reuse for your that you could use for when composing a workflow. So one of the PhD student is working on a recommender system for scientific workflow management system using machine learning and deep learning. Okay. Yeah, we are also working on program comprehension, like a abstract tree generation that could be used for using natural language processing. So it is again software analytics. So we are using topic modeling technique like LDA, LSI to actually get topics from a sequence of methods, and this grouping could be used to represent a sequence of methods at an abstract level to better understand the source code. And we are also using like natural language processing technique like an doc2vec, cosine. All these things are involved to generate the tree. So here it offers a tree representation of the source code, and you can actually explore the source code from a higher level representation to a lower level representation to navigate the source code in an understandable way. And it is really helpful for the new developers, and you can even compare different versions of the source code using this tool, and we are working on this. Yeah, I reached to the end of my talk. In my research, I focus on engineering usable, scalable, and collaborative scientific workflow management system. So we have already developed SciWorks and VSciFlow, but we are still developing these two platforms to make them more usable for the scientists. And I also focus on software analytics for quality software development. Yeah, Thank you. If you have any question, please feel free to ask. Thank you. Can you hear me?
Yes, thank you, ma'am. Thank you so much. It's very nice topic. Yes, any questions from student side? No, no questions, ma'am. Thank you,
No
ma'am.
question. Okay. Okay. Thank you. I'm happy that I didn't get disconnected. It was okay. Yeah. Thank you. Thank you for the opportunity. Yeah. I totally appreciate it.
Thank you, ma'am. Thank you so much.
And gentlemen, at the outset, I, Ujjwal Srivastav and Amulya Yadav, express a warm and respectful welcome to the 14th International Conference, Confluence 2024, Cloud Computing, Data Science and Engineering, organized by the Department of Computer Science and Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida. As one of the leading global universities, Amity University is dedicated towards its responsibility of imparting its students with strong foundation and a platform for empirical inquisition. With this agenda, Confluence 2024 intends to bring together professionals, academics, industries, experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of next generation technologies. May I invite Dr. Neha Tyagi ma'am, Associate Professor from Amity University, Noida, up to present a sapling to our esteemed speaker, Professor Dr. Giancarlo Fortino, University of Calabria, Italy.
Yeah, welcome, sir. From on the behalf of Amity University, Noida, I, Dr. Neha Tyagi, presenting the Tulsi sapling to you.
It is our great privilege and honor to have Professor Dr. Giancarlo Fortino amongst us. Giancarlo Fortino, an IEEE Fellow since 2022, is a full professor of computer engineering at the University of Calabria, Italy. With a PhD from the same institution, he holds various positions internationally, including distinguished professorships in China, a senior research fellow in Italy, and roles as a visiting scientist and lecturer for IEEE Censors Council. He is highly cited in computer science, focuses on research areas such as wearable computing systems, e-health, Internet of Things, and agent-based computing. His extensive contributions include over 600 papers, numerous editorial roles, and leadership positions in international collaborations, showcasing his significant impact in the field. Now I request Professor Dr. Giancarlo Fortino, sir, to kindly address the gathering with his words of wisdom. Please, sir.
I'm pretty glad to be here, to deliver this keynote in your very interesting conference. So the topic of today, as you may see, is edge intelligence for next generation IoT systems. This is the outline. I will try, first of all, to define what is edge intelligence in the context of Internet of Things ecosystems. Then I will give you just some short view along with considerations about our European project, Horizon Europe project on machine learning applied to the device edge cloud continuum. I will give you also some information about our research on the integration of digital twin and edge intelligence in the context of smart city. And I will conclude just with our methodology that I'd like to promote in your framework, that is edge mining sim. And then, of course, I will give space to questions, okay? To questions. First of all, we need to agree, let's say, on the definition of Internet of Things, okay? We got multiple definitions in the related work of Internet of Things, but I just selected two of them. The first one is comes from the telecommunication world, and Internet of Things is a worldwide planetary networks of interconnected smart objects that could interact with each other through communication protocols, standard communication protocols, in order to achieve common goals. Okay, so this is one of the multiple definitions that you can find in the literature, okay, about Internet of Things. Indeed, I'd like to provide my definition, okay, of Internet of Things, the definition I use in my group in order to perform research on Internet of Things. So you can see that Internet of Things could be considered a loosely coupled decentralized system of cooperating smart objects. So this is, you know, the definition I prefer, because it is very close to an artificial intelligence definition of Internet of Things based on the concept of multi-agent systems. So smart objects are agents in a multi-agent system, and our smart objects are able to provide physical and cyber services. Okay, they can interact with other smart objects, they can interact with the surrounding environment, they can interact with humans, okay, in order to provide services, new services, in order to achieve common goals. Okay, now we are in the third generation of Internet of Things. So the very first generation was characterized by RFID systems, by microcontroller, by wireless sensor networks. The second one, and specifically the third one, is characterized by a full integration between devices at the edge and software systems, information systems in factories, in companies, in whatever institution. So this is fundamental in order to apply artificial intelligence techniques in order to provide AI-driven big data analytics. What's the next generation of IoT? The next generation will be fully driven by artificial intelligence, specifically at the edge. So it's what we call edge AI-driven Internet of Things. And of course, you see, you know, the market of IoT is increasing. So the trend that you can see is an increasing trend from different perspectives, from the IoT security, IoT hardware, IoT services, IoT software. So you see that there is almost plus 20% each year. And this is an expectation that we got in the coming year till 2027. So what's the final goal in creating IoT systems? Here the idea is to define research and technology in order to fuel IoT ecosystems where machines and humans can interact with each other in order to provide new and diversified services. In all of this, it's going to be fundamentally important to have edge computing. Not only edge computing, but artificial intelligence-driven edge computing. Now, what's the problem? The problem is that IoT devices at the edge are able to generate huge data, a lot of data. So you can see that over 150 billion of devices are currently connected to the internet, generating more than 90 zettabytes of data at the network edge. So this is something that we cannot manage if we would like to move this data into the core of the network. So we need to apply our machine learning, artificial intelligence algorithms directly at the edge in order, you know, to provide a solution to this problem. So we need to move the computation rather than the data. So the data will be there, the computation will be moved. So this is the message through the edge intelligent computation. Which kind of intelligence? It's very difficult, to define what is intelligence from the artificial viewpoint. Okay, but anyway, intelligence means that we are able to provide a bunch of methods and algorithms that are able to understand, to extract knowledge starting from the data. This is something that we currently do, okay, apart from using other kinds of artificial intelligence. But indeed, artificial intelligence would like to simulate the human intelligence, and specifically the behaviors typical of the human intelligence, like planning or learning or reasoning. Okay, so these activities should be placed at the edge. Okay, should be placed at the edge. And in order to place these activities at the edge, we need to screw up new algorithms, new methods, because the current methods we have, they work pretty well in a centralized or cloud-based environment. But when we try to massively distribute these algorithms, we got problems. Okay, we got problems. So the idea with the edge intelligence is just to have an environment in which you see this architecture. So the architecture is usually a 3-layered architecture. On the bottom, you got devices. In the middle, you got an edge layer that could contain edge servers of different computation capabilities. So you can have really powerful edge servers, but you could also have a Raspberry Pi 5, okay, that could provide computation capabilities. Indeed, you could also have computation capabilities in the device layer till you reach the cloud layer. So this is the typical 3-layer architecture that you can use in order to support the so-called device edge cloud continuum. So you need different benefits. You need faster response times, you need improved reliability, you need enhanced data security. So you need many challenges that could be fulfilled, addressed using this architecture, and in particular using edge intelligence. But let's try to define better what is edge intelligence. So providing, the edge computing capabilities, we need a truly distributed and pervasive approach that allows us to process and analyze data as much as possible close to the device layer. And this should be done in, let's say, in an intelligent way, okay? In an intelligent way, in a smart way, in order to improve decision-making, in order to increase operational efficiency, in order to reduce the costs, the latency, the data traffic. And then we have also to take into account privacy and security in our solution, along with scalability and reliability. So what we did a systematic meta survey in order to understand very well what is edge intelligence. And from this meta survey, we had several important results and considerations. So you see that we used the Prisma methodology in order to conduct this survey. So you can find the details of this survey in the publication at the bottom, published recently in Big Data Computing, Cognitive Computing. The name of the paper is a systematic disclosing edge intelligence, a systematic meta survey. So if you'd like to know, all the detailed aspects of this paper, please download the paper, because the paper is open, so open access. So you can download the paper, you can read the paper. But I'd like to give you just the insights we had carrying out this meta survey. Okay, so these are the research questions we explored. Specifically, what are the current definitions or interpretation of edge intelligence? So you got a lot of definition, different interpretations. So we need to understand very well what is edge intelligence, what are the reference architectures, what are the main topics, what are the key techniques in order to support implementation of edge intelligence, and what are the ongoing efforts and the future research challenges in this domain. And I'd like just to focus on this on the very first research question about the definition. So we were able to identify two different definitions. One is we named evolutionary, and the second one revolutionary. Evolutionary means that edge intelligence is the next stage of edge computing. So it is edge computing plus artificial intelligence, okay? But on the other side, we were able to identify many papers in which the definition was revolutionary. It means that edge AI is not a next stage of edge computing, but is a novel paradigm combining different multiple approaches to achieve distributed intelligence. This is very interesting. I like much more this second definition with respect to the first one. Okay, so I'd like to give you this definition, a revolutionary definition, so a novel paradigm combining multiple approaches to achieve distributed intelligence. And this is important in order to promote what we call continuum between edge and cloud. So in order to have this continuum between edge and cloud, we need to have edge intelligence completely, massively distributed in our system. Another important point, another important aspect is what is AI for edge, what is AI on edge. These are two different perspectives that we need to define well in order to have this full-fledged edge intelligent vision. AI for edge is, okay, let's try to optimize edge computing by using popular AI techniques or new AI techniques. Okay, so I use AI in order to optimize edge computing. On the other side, we have AI on edge. It means that I'd like to execute my AI algorithms on edge computing platforms, and then I have to provide methods, algorithms, in order to be able to execute AI on such even very tiny edge devices. Okay, so this is another important aspect that you have to consider when you approach edge intelligence. And of course, at the end of the day, we were able to select 12 important works, seminal works about surveying the state of the art of edge intelligence. And we were able to classify such works along with different dimensions. But I leave you, these details when you download the paper. Please download the paper because, again, it's in open source, and you read the paper in details. What are the lessons learned by executing this survey? IoT systems and related services require edge intelligence in order to unleash their potential. So we need to have edge intelligence, specifically in an architecture that is a 3-tier architecture, device edge cloud continuum. And of course, we need standardization. Standardization usually comes later, okay, after many years of research and development. But for example, we already have an example of standardization like HC mobile edge computing. Okay, this is an example, interesting example of standardization of mobile edge computation. And of course, we need to have important architecture supporting this paradigm. One of such architecture comes from our Horizon Europe project that is called MLC SOPs, that involves many partners in Europe. As you may see, partners coming from Italy, from my country, but even partners coming from France, from Portugal, from Ireland, from Greece, from the Netherlands, and so on and so forth. Okay, so this is an important consortium. It's a almost 7 million euros project. Okay, and we are defining a very interesting architecture. As you can see here, this is the high-level architecture of MLSE SOPs, And this is an architecture based on the MAPE paradigm, that is monitor, analyze, plan, and execute, strongly based on the concept of edge intelligence, and also on the reuse of libraries of machine learning algorithms that could be downloaded and installed on demand in any place, any location of this infrastructure, even inside very tiny devices. Okay. And we selected a multi-agent system approach. So you can see, the faces that are agents. So we got agents in each layer of our architecture, in the far edge, in the devices, in the smart edge, in the smart devices, in the edge infrastructure, in the server, in the edge server, till in the cloud infrastructure. Okay, so we are able to monitor such agents and to control such agents in order to create plans and execute such plans in our infrastructure. Everything will be tested in 2 use cases. One is related to smart agriculture, one is related to smart city, and also we will have in a lab test beds on smart wearable system and smart drone systems. Okay, now I will try to move on. So let me skip just this preliminary part in order to focus on our concept of opportunistic digital twins that merges the concept, the typical concept of digital twin that you can see in the definition of Hughes 2018, that is an executable virtual model of a physical thing or system with edge intelligence. So if you integrate the concept of digital twin with the concept of edge intelligence, you got this concept of opportunistic, in which the digital twin based on data is able to create itself. So this is a very interesting aspect, to create digital twins using a bottom-up approach, not a top-down approach. So we don't have any model, reference model. We just create a digital twin starting from the data, using edge intelligence, using machine learning techniques in order to create our digital twin. And we did so specifically in a use case that is a traffic monitoring system. So we have a digital twin of a traffic lights that emerges from the data. So we are able to construct our digital twin, our traffic monitoring system, based on the data we are able to collect from a traffic lights about the vehicles, about the trajectories, about the pollution, about multiple dimensions. And on the basis of these multiple dimensions, we are able to create our digital twins. So this is some details about the infrastructure, the technological infrastructure of our system. So you can see the 3 layers: the device layer, the middleware layer, the edge layer, and the cloud layer, with different technologies. So this is also interesting because we merged multiple technologies in order to create our final system, and also in order to evaluate the system. The system at the end of the day was evaluated in order to understand the accuracy of the system with respect to the same development, the development of the same system, by using consolidated cloud-based technologies. And then we can say that the use of edge intelligence is key in order to reduce the latency, in order to reduce the bandwidth, in order to reduce the computation efforts, and to have an accuracy that is similar or almost similar to the accuracy that could be achieved using a centralized approach. And last but not least, we also defined a methodology. So my message here is, okay, you got algorithms, you got methods, you apply your algorithm, your methods in order to have important use cases that you can study and analyze. But how to build your system, okay? In this direction, you need a methodology. So we defined this methodology that is called a simulation-driven methodology for IoT data mining based on edge computing, that appeared in 2021 in ACM Transactions on Internet technology. So I warmly advise you, to download the paper, to read the paper, to go into details, okay, about this methodology. And this methodology was preliminary for our work, in the sense that we use this methodology in order to build edge AI IoT systems. Okay, as you may see, IoT data mining is different from centralized data mining. So we work at the edge. We don't work at the cloud anymore. And of course, even the requirements are fully different with respect to the requirements data mining got at the centralized level. Okay, so we need to take into account such requirements for data mining of IoT systems. Okay, and what's the final product? The final product is a let's say general specialization, let's see, of a well-known well-known methodology in data mining that is named CRISP methodology, specialized for the edge intelligence domain, okay, in which we would like to apply machine learning techniques on data coming from our IoT devices. And then you can see, this process starting with the IoT domain analysis, then the IoT data analysis, the data mining setting. An important phase, and this is something on which I will spend just a couple of minutes, is simulation. How to validate your system from a functional and non-functional viewpoint. Then you need to validate your system using a simulator that provides you insights about functional and non-functional perspectives. So we used this simulation, we enhanced this simulation that is named Edge Cloud Sim. You can see that is the three-layered architecture of edge computing. So according to this simulator, we are able to simulate whatever system in order, again, to validate it from functional, non-functional viewpoint. And this is fundamental, is, let's say, preliminary in order to finally and concretely implement our IoT system. Okay, let's provide some final remark. So IoT Edge Cloud Continuum is becoming a best practice. So you need to use this paradigm in order to develop next generation IoT systems. You need to push intelligence at the edge. You don't have to apply AI algorithms just on the cloud. You need to start at the edge, even in very tiny devices. Another important aspect is to reuse the paradigm of autonomic computing, the MAPE paradigm, and then exploit multi-agent systems and opportunistic digital twins in the development of your IoT systems. And last but not least, methodologies are fundamental. So you need to exploit a methodology in order to develop your IoT system. And of course, if some of you will ask about trust, security, privacy, definitely. I have not spoken about trust, security, and privacy, but you need to consider them in the whole system. They are, let's say, transversal requirements that you have to fulfill. Maybe in another talk. Okay. Publication possibility. I'm the editor-in-chief of this series. So if you got ideas about edited or authored books, please, not proceedings, because we don't welcome proceedings. So edited and authored books. Thank you very much for your attention. Thank you.
With this, we conclude the session. We hope that it.
Thank you, sir. Thank you, Professor Giancarlo. That was very nice talk on the edge cloud computing. Yes, please.
We hope that it was an enriching and informative experience. I, once again, on behalf of the fraternity of MIT University, Uttar Pradesh, thank all the guests and dignitaries for their significant presence. We would also like to thank the students for their cooperation. Thank you, everyone.
Thank you.
Thank you.
My topic is cyber risk management trends, navigating the evolving landscape in this year. Just to introduce myself, I'm Professor Kira Yakimowski. I'm from Macedonia, Europe. I work at American University of Europe, FON at Skopje, the capital of Macedonia. So I teach subjects in computer networks and cybersecurity. I'm IEEE senior member also. I'm cybersecurity consultant in Australian firewall company. So that's all about me in short. I will start now with my topic for today. This is very hot topic in cybersecurity. Cyber risk management is very important. So I divided in 4 parts this presentation. I hope that I will have time to explain all that I want in this presentation. First part is to see just a short overview of the importance of cyber risk management, definition, what is cyber risk management. Then I will talk about the cybersecurity landscape in cyber risk management in this year and previous year. Then I will introduce the key trends that will shape risk management strategies in this year. And the last 4 part, I will demonstrate what are my current researchers in cyber risk management development and tools that are very important and applications for cyber risk assessment and treatment in companies. So what is cyber risk? First, to understand, there is a slight difference between cyber risk and IT risk in the academy. Actually, IT risk is more related to likelihood and consequences of the threat to information, CIA triada, confidentiality, availability, and integrity. It also includes third-party security risks, awareness of the employees about cyber threats, and incident response ineffectiveness. On the other side, cyber risk or cybersecurity risk is exposure to harm or loss to computer systems or networks that is resulting from breach or some type of cyber attack on information systems and networks, or cyber risk is possible loss or harm related to breach of technical infrastructure or unauthorized use of technology in specific organization. So there is this kind of definition difference in IT risk and cyber risk. Then what is cybersecurity risk management? It is an ongoing process in which we have to identify, to analyze, to describe potential events and circumstances that can produce impacts to information security objectives. So cybersecurity risk management is divided in 2 main parts, or I would say phases: risk assessment and risk treatment. And they are both very important. What is risk assessment? It's assessment of the risks that should include sophisticated tools that are assessing the cyber risks in one computer network in specific company. Then after precise assessment, the next phase is treatment of the detected risks that are in this first phase of risk assessment, detected and evaluated. So these 2 processes are very important for the cyber risk management process. There are actually key areas for implementation, maintenance of successful cyber risk management implementation in every organization. I deliberately mention here 2 important standards regarding cyber risk management. It's 2700P and 2700, and they are both very important for cyber risk management. There are both ISO standards that treat cyber risk management. 27005 is actually about cyber risk management with focus on cyber risk management, and in 27001 we have also, especially in the annex with controls, a lot of controls related to cyber risk assessment, treatment, and management. Also in the cyber risk management, very important are regular reviews that are actually they are very important because we must have review when we assess and treat cyber risks in order to check the status of the ongoing risks, to check where we are in the process of treating the cyber risks and defining the levels of the risks. So for successful management, very important are regular reviews. Cybersecurity risk management is treated in one of my papers. Its title is Position in Cybersecurity Risk Management within a Consolidated Security Platform, and it is actually published last year in US Press. And in this paper, I explain a lot about novelty in cybersecurity risk management. In this research, I'm covering with my colleagues from the Australian company extensively the application of metrics that are intended to reduce uncertainty about measures for risk assessment and mitigation resulting from risk treatment. So we are also putting attention on cyber threat intelligence that is being leveraged to provide enhancement risk estimation and evaluation of existing controls with threat actors together with techniques, tactics, and procedures that are for this treatment and process very important. Okay, the second part of this presentation is on cybersecurity landscape in previous year and this year. In previous year, we are just beginning this year, we are January, so in the previous year, we witnessed a significant increase in cyber attacks if we compare with 2022. And we notice increasement in ransomware attacks, for example, they are nearly doubled. Also, data breaches are increased by 60%, and also phishing attacks are increased. 300,000 users were downloading banking Tran applications. This source is from our cybersecurity threats report for 2023. Impact from cyber attacks are very big. Average cost of data breach increased in 2023 by 15% to $4.45 million. This source is by IBM Security. And targets are all, not just big companies, important critical infrastructure institutions and organizations. We have also witnessed small businesses that are hit hard by these cyber attacks. So in this year, what we expect about cybersecurity landscape? There is great challenge of cyber risk quantification, because quantifying the cyber risk is major challenge for organizations. Cyber risk quantification tools are very important, but few of them can be used effectively to make detailed and accurate decisions about the security posture. So in this year, organizations will need to focus more on using cyber risk quantification data to drive better results. That is one of the challenges that are in the cybersecurity landscape in this year. Then another factor in this cybersecurity landscape is emergence of zero trust programs. Zero trust security is a very attractive theme last year and this year also. It's about designing security model that assumes that no one is trusted inside or outside the network. So in this year, we will see a lot of organizations that are adopting this kind of programs with zero trust in order to improve their cybersecurity resilience in the companies. Another interesting area in cybersecurity landscape expected this year is the role of threat detection, investigation, and response capabilities. This term, threat detection, investigation, and response, is implemented in a lot of cybersecurity companies in the world that offer services and products that are up to date. So these are very essential: detection, investigation, and response. These three parts of this whole term, TDIR, are very important in order to quickly identify, investigate, and respond to cyber attacks. So in this year, organizations and companies will need to invest more in this kind of capabilities in order to minimize the damage that could be caused by cyber attacks in their companies. Another important aspect in the cybersecurity aspect in this year is human-centric security. So organizations should put more human-centric approach to security in order to take into account more people in the role of causing and preventing cyber attacks. And in this part, of course, cybersecurity awareness trainings are very important in order to make better improvement in this part in organizations. Because the human part in cybersecurity is most important, and the weakest link in the whole cybersecurity complex theme. So another important factor in this landscape for this year is shift the role of CISO in our organizations. So Chief Information Security Officer is a very important working position in each organization that wants to protect from cyber attacks its devices and assets. So this year, CISOs will need to be more than just technical experts. They will need to be strong communicators, also business leaders who can effectively advocate cybersecurity within their organization. They should be more related to human resources management, to end-to-end security operations, to business continuity in the company, in the compliance field also. So this role will have to be more involved in more than just technical part of the cybersecurity. That was the second topic of this presentation. The third topic is about what are cyber risk trends that should be expected this year. So this year, cyber risks are evolving, and last couple of past few years are evolving at a fast pace. They're becoming great concern for every company organization. Also, in the world of technology, digital era is advancing to era of cognitive intelligence and generative artificial intelligence. So this technology evolvement and improvement also helps improvement of the cyber risk management. But on the other side, it also helps the bad actors to launch more sophisticated cyber attacks. So that's why innovations in cyber risk management is very important in order to be in parallel with the bad actors who are also using artificial intelligence tools for making more sophisticated attacks. And that's why cybersecurity should be more implemented in cyber risk management in novel technologies. But that is actually not happening in real life because innovations are more important to factors that are producing new technologies. That's why they should put more attention to cyber risk process in order also protect people, critical infrastructure using these new technologies. Another trend in this year is artificial intelligence powered cyber risk management tools. There is a lot of potential in artificial intelligence for building a robust cyber risk management strategy because there are new sophisticated threats. According to Gartner, 35% of organizations are already using artificial intelligence risk management tools. Well, 56% are actively exploring these kind of solutions. So because cyber risk landscape is becoming more complex, this kind of cyber risk management tools that are powered with artificial intelligence algorithms will be more than needed in order to detecting more and more sophisticated threats. Another cyber risk trend for this year is also autonomous risk assessment for improved accuracy in decision making. Till now, we are more based on scenario-based approach when we are using methodologies for cyber risk quantification. And that is very complex because we have a lot of data and different kinds of assets. That's why better cyber risk quantification is when we are based on the assets And that is one of the tools in my papers that I actually created last year. This picture is actually cyber risk assessment that is based on asset types. This is asset type application and my controls that are regarding this type of asset. Another cyber risk trend is regulatory obligations and automated compliance, because we have a lot of increasement in cyber threats and impacts. Regulators are more focusing now on direct regulations for cybersecurity risk management, not just issuing guidelines for cyber risk management. So recent regulations like DORA and Cyber Resilience Act in the European Union, then Digital Personal Data Protection Act in India, for example, or SEC cybersecurity rules in USA. They are requiring organizations to implement more stringent, more robust cyber risk management programs. So automated and robust compliance platform is solution to avoid the risk of failing to comply with new regulations and rules that are in this field. So this is also a trend that is ongoing. Another trend is, this is also the same thing. This is an example of how regulatory obligations are in practice implemented with automated compliance. This is, for example, DLP application for data loss protection in XDR appliance from Red Piranha Crystal Eye product that is developed to help organizations to comply with ISO 27002 framework. And one of these controls in this framework is actually for data loss protection. It's about data leakage prevention. Another cyber risk trend is more sophisticated attacks. We mentioned this before in this presentation, that attacks are more and more sophisticated. This is happening because of the development of generative artificial intelligence. It was used in 2023 in phishing, in exploiting Internet of Things vulnerabilities, in ransomware attacks, etc. So we have increased number of sophisticated attacks. On this picture, actually, this is threat intelligence report for this last week, from 9th of and to 15th of January. We can see in this threat intelligence report new threat detection that are added. So artificial intelligence powered and automated cyber risk management solutions are more than needed in this year in order to deal with the use of this kind of AI tools for malicious purposes for bad actors. Another trend is third-party cyber risks. Third parties are very connected to each company organization, so they should be also in the umbrella of cyber risk management included, with normally artificial intelligence help. So this is also very important trend that is increasing this year. Another trend is cybersecurity investments and insurance costs. We noticed increase by 14.3% to reach $250 billion that are spending on cybersecurity and risk management this year. So this is expectation that puts organizations to realize the increased cyber risks and costs of cyber attacks. And key sectors of investment are cloud security, artificial intelligence, Internet of Things security, development, SecOps, security operations, identity access management, endpoint security, cybersecurity, insurance. These are key sectors that are put on the investment that are expected to happen this year. Another cyber risk trend is also insider threats and risk-aware culture, because as I mentioned before, human factor is the biggest reason for data breaches. That's why this is also a very important trend. Cybersecurity awareness programs are more and more implemented and realized that are very important in order to have solid cybersecurity protection. And now the last part of my presentation is demonstration of research results that I have made in cyber risk management in the previous 2 years. So one of my papers is talking about automation improvement in cyber risk management. This is actually a framework that is designed for me in order to propose cybersecurity risk management life cycle, including risk audit tool, risk server, GRC platform for governance, risk and compliance, and CSR process. CSR process is cybersecurity review process. So we have relations between these four entities in order to make the whole life cycle of cybersecurity risk management in one company. And this is explanation of what are these phases in this the whole framework. First, client answers questions regarding evaluating the cyber risks. After these questions are answered, we don't have actually very detailed level of pending risks. That's why client answers also CSR detailed questions from these categories on the pending risks. Then compliance teams maps the answers with the pending risks, and compliance team reviews them, evaluates the level of each risk, and then these risks with defined levels are sent to the risks. Compliance team performs tasks to manage the risk, like plan mitigation, perform reviews, status of the risk, defining changing status, etc. And then risk report gets automatically updated based on these tasks by the compliance team in the risk server. Next phase is the results from these risk reports are used as input of the CSR report, and findings are used for managing assets, risks, controls, policies in the GRC platform. GRC platform is one of these four main elements that is very important regarding controls, policies of the assets and treating risks. And the last phase is review. Regarding that review, we have calendar that could be used in the GRC platform to initiate alarms for reviews of the whole CSR process. So that is one of my researches. Another research is regarding this cyber risk management tool explained here. So this cyber risk management tools is actually automating the generation of cybersecurity levels. Cybersecurity levels in this work are defined as a significant, low, medium, high, and very high risks. In some methodologies, we can also have term critical for very high. It's same. These are the five main levels that are actually defining the level of risks that could, and the level of risk is very important in order to evaluate the damage that could be caused by this risk. So what is this tool about? This is cyber risk assessment tool that is web-based. We develop web application for this cyber risk assessment tool, and it is asset-based. As I said, one of the cyber risk trends are not scenario-based, but asset-based cyber risk management. This is actually asset-based cyber risk management, because cyber risks are here treating asset types. For each asset type, we have group of cyber risks related to that asset type. For example, on this picture, there is a box that shows risks for asset type application. We cannot see here risk because we have to click here to evaluate the risks. We don't have time for that. So after generating the risks, we have more clear picture what is the cyber risk for appropriate asset, and what is the level of the risk. And this is compliant with CIS version 8 standard. And also in this phase, mapping with standards is very important. So I developed here also mapping of the generated risks from this tool with CIS controls version 8 and ISO 27008 Annex A controls. That is very important in order to be compliant with world standards in this field. Also, it's very important to map the cyber risk with XDR appliance. And I also did that. This appliance is from Red Piranha Crystal IAM client that is mapped with pending risks from this tool. So we have here not just theory, but compliance with standards, but practice, because we have also here included XDR plans that should be set to minimize these risks and to be compliant. So I can conclude that comprehensive approach of the artificial intelligence powered cybersecurity risk management includes new platforms and updated standards, and that is very important. Also, security controls and policies and procedures regarding compliance to standards. This is very important, and also to have the whole life cycle of cyber risk management covered. Dealing cyber risk management in the organizations, it's very complex. So we must consider approaches that I already presented in this presentation that could help cybersecurity experts to improve cyber risk management in the companies and to have accurate cyber risk assessment. This is connected also with accurate classification of information, because asset value is very related to what is inside that asset. Also, proper selection and usage of cyber risk management tools is also very important, because it will help organizations to accurately assess the cyber risks, and also to do this more easily with definition of accurate risk levels and appropriate security controls that are related to the appropriate risks. And these security controls must be based on approved standards and policies. That's why I mentioned here CIS version 8, ISO 27001. So, right, cyber risk management is evolving in one of the, I would say, in one of the key factors for obtaining success in any type of organizations, especially in this era of when we have a lot of increasement in technology, in artificial intelligence, machine learning, deep learning. Also, quantum computing is very important, and it is what is expected in the next few years, because in the very near future it will be implemented in the modern computer systems and networks, and also cryptography will be changed totally with this quantum computing. So cyber attacks will be changed, and etc. So we must keep with the changes in technology up to date with also development of cyber risk management. So I will now end with this presentation. The time is past. Thank you for your attention. If you have questions, I'm here.
Firstly, I'd like to thank this beautiful and highly informative presentation. So I would like to know that if someone wants to go into the field of cybersecurity, what are the current career options available? And also, like, how can he start, like the foundations and all?
A very good question. So in order to be successful in cyber risk career, first you must have basics that is learned in the Faculty of Informatics regarding subjects like computer networks and systems, and understanding the computer networks and systems is the basis. Computer administration is basis for development of cybersecurity. If you don't know what is IP address and what is subnet mask, and what are protocols in computer networks, how you will protect computer networks. That's why this is learned in the faculties. What is important to start career in cybersecurity is to start with, if in the faculty you have cybersecurity courses, it is also good chance to learn the basics of cybersecurity. But to be expert in cybersecurity, you need more. If you are not finishing Faculty of Cybersecurity study program, you will need, for example, to enroll on some courses. For example, EC Council is very good And on our university, we're actually first university in our country that implemented academia partnership with EC Council. EC Council is institution that have a lot of courses. It is informal faculty education, I would say, because they have a lot of courses in different fields. For example, in ethical hacking, in incident response, in network defense, in different kind of areas in cybersecurity. So this is also very good for becoming cybersecurity expert. And these certificates are very appreciated all around the world. So I will say first basics, computer networks understanding, then starting to start enroll on some cybersecurity course in order to start putting more knowledge on cybersecurity science.
Okay, so thank you for this response.
Yes, but if you have my contact, you can. I can have also video conference with you if you like to have more info about this after this meeting.
All right, it's yours, sir. Thank you.
Thank you very much.
Thank you, sir, for your enlightening session.
Hello, again, I'm very glad to be invited to this event, Cloud Computer Data Science and Engineering, your conference. I was participant at this conference last year, and I'm very glad to be again. So today I want to present the topic world-level language identification for code switching corpus. Some words about me. I have a PhD degree in computer science. I have a scientific publication related with the natural language processing. I'm a participant in many international projects such as ACOMIN, MASTIS, UNIDIVE, COS, etc. Usually it's a European project. I have more than 8 years of practical experience on real-life projects in private IT companies. And I'm a member of the Special Interested Group on Slavic Natural Language Processing. This group works with the Ukrainian, also with Ukrainian language and other Slavic languages. I'm the organizer of the International Conference, Computational Linguistics and Intelligence Systems. And I'm a manager of the Clarin Knowledge Center for Ukrainian language. Okay. So first of all, we need to define what is a code switching. Yeah. So code switching is the practice of moving back and forth between two languages or between two dialects or register the same language at one time. Code switching occurs far or more often in conversation than in writing. It's also called code mixing and style shifting, but the last is the less popular name. It's studied by linguists to examine when people do it, such as under what difficulties do bilingual speakers switches from one to another. And it is studied by psychologists to determine why people do it, why people switch from one language to other, and such as how it's related to their belong to group or the surround context of the conversation. 2 years ago, when I did not ever think about the code switching, what is the code switching corpus, etc., I understand that it's really difficult task to apply different natural language processing methods and approaches to code switching data. First of all, we worked with the language identification task because it's a base task for other. Yeah. After this task, you can apply morphological, syntactic parser, etc. But our text is mixed, and it's not always clear what language a person speaks or writes in. But as it has already been mentioned, code switching is usually more common in conversation speech than in textual speech. So it's especially important for the social networks or for the forums, transcripts, podcast, video transcripts, etc. And why people use code switching? Because when we switch from one language to other, we spend a lot of energy. Yeah, we need to spend more time, and it's no, it does not link with the natural language processing, but sometimes it's interesting why people use such a structure in their text. So some reasons of code switch, which we met in our data set, are mood of speaker, to show identity, to quiet other people, to add expression and personality. For example, we met in our data set citation. So people speak in Russian, and after this they switch in Ukrainian. Then they try to sign the law document. Sometimes people speak in Ukrainian and use phrases in Russian. So it can be metaphors or something else. I need to mention that in our research we work with the Ukrainian Russian code switching corpora of Ukrainian parliament. It's a transcripts. There contains transcripts from the audio files of our parliament. And on this slide, you can see two diagrams how we use in Ukraine Ukrainian and Russian languages. And as I know, in India, it's also very popular and actual task here, because you have a lot of different languages, dialects, and English. So a lot of people know 2 or more languages. Yeah. So my colleagues and I currently work with the Ukrainian Russian code switching corpus, and you can see, for example, on these diagrams, you can see two different years, yeah, 2070 and 2020, 2022. So two diagrams. One diagram show how we use language in everyday life, and other how we use language at university and at work. And you can see that a lot of people use Ukrainian. Some people, less people, use Russian, but a lot of people use both languages in their life. And what is the reasons? Yeah, the main reasons for the strong role of research in the text processing and code switching. First of all, the need to process social media network or social media data. Yeah, before the proliferation of social media platforms, it was more common to observe code switching in spoken language and not so much in writing language. There is not the case anyone, as the multilingual users tend to combine the language they speak on social media. The second, the increased release of voice operating devices. Yeah, you know that now a lot of companies create different chatbots for different domains. Yeah, and now that smart assistants are becoming more and more accessible, they have started to realize that assumption users will interact with natural language processing technology as monolingual speakers in very restrictive and does not fulfill the needs of real-world users. Because in real life, people usually use different languages, sometimes combine, mix them, so it's really difficult. So for the next slide, you can see some popular tasks for code switching corpora from the NLP era. Yeah, the most popular is language identification. Now we are working with, especially with language identification on the word level. It is the most frequently task, yeah, for code switching. The second is sentiment analysis, name entity recognition, part of speech tagger, abusive language identification, ACR, language modeling, and machine translation. But each of them cannot work without the language identification task because it's a base of for each of them. You can see more information in this paper. I put the description of this paper bottom of the slide, so you can find more information about this research. It's really interesting. And what is the source of the code switching data set in the literature? First of all, it's social media. Yeah, social media, and I think it's forums. And sometimes when people or blogs and people comment some information, they use very special language. Yeah, it's not writing, it's not speaking, but it's real language. Speech recording and transcription. So transcription, it's our case, yeah, because we use transcription for our research. News, dialogues, books, government document, it's also about us, and tree bank. About the tree bank, I also put publication at the end of this presentation about the Turkish-Germany tree bank for the code switching corpus. It's really interesting because usually people for the language identification and other tasks use only n-grams or such as feature, yeah, and word embedding, but few people use additional features, yeah, morphological features, syntactic features, and these guys prepare this tree-bank for this corpus, and I think additional features can be very useful for the improvement of this task. So, and what is the types of code switching? Yeah, the first is intersectional. Intersectional code switching occurs outside the sentences or clause. In other words, a complete sentence clause in other language is followed by one in another language. It is also called extrasensual switching. I think it's more easily type of code switching because if you know a lot of different language identification frameworks which identify language work with the sentence level or short sentence level or phrases, yeah, but so it's not so difficult from one side, yeah. The second type is intersential. Intersential code switching occurs within the sentence or clause. A part of the sentence is in one language variety and is followed by one from another language variety. It is this variant is more interesting because we combine different phrases in one sentence inside one sentence, and we met these cases a lot in our data set. The next level is tag level or word level, yeah. Switching brings a tag phrase or word from one language into another language, and it is also very difficult. I think it's one of the difficult tasks because sometimes sentence is very short and contains 3 words, and these words from different languages. It's a really difficult task to define what is language. Yeah, we can find. And the last is the interword. Interword switching occurs within a word, such as a morpheme level. It's really interesting. I don't know about all languages, but I met this information about the German Turkish corpus when, and also I know about this in our data set because we also met a lot of different interword code switching. So this case, when we have one word, but some morphemes in this word come from different languages. For example, root from one language, but suffix from other language, or ending from other languages. And in one word, we combine different features from different words. It's so it's usually in papers we can see such examples, but in real life, this interword can be in different levels, and we met very difficult cases. So intersection switching is usually the primary focus on code switching studies. It involves a blending of grammar structure from different languages. The other types simplify follow the grammar of other language to the other. Interstitial switching is of two types, alternation or insertion. The form involves the creation of a new grammar, combine the grammar of both languages. The latter simply inserts element from one language into the morphosyntactical frame of the other. So it's this classification of type of code switching. I think it's simplified. Yeah. So I think so. If we deeply involved in this topic, it's more difficult. So on this slide, you can see different type of methods which used for the code mixing NLP. So the author of this research prepared two diagrams because they analyze publication from different resources, but the situation is very similar. So we have small numbers of methods which based on rule or linguistic contains. These methods are not so popular now. Yeah. More than 50% of methods are statistical. They use n-grams and additional features. These are such methods as naive bias, support vector machine, random fields, etc. And the last group is a neural network or deep learning methods and pre-trained models. Also, last 2 years, it's the most popular area for, I think, for all NLP tasks. But you need to understand that different methods can be applied for both for different languages, but it depends also what is the family of these languages. If we talk about, for example, about the Polish and English, this is languages from different families, but they use very similar alphabet. It's more difficult than we compare languages from with different alphabet, of course. And statistical approach can be very good, maybe variant for this case. But in our case, Ukrainian and Russian alphabets are very similar, so we need to use more interesting methods. Maybe based on the deep learning, for some models, for additional features, etc. So I prepare some examples of code switching for you if you're interested in this in this topic. So on the left you can see example 1 shows code switching between Hindi and English, and example 2 between Spanish and English. To the left, you can see example from our corpus. So you can see code switching between Ukrainian and Russian, and you can see a translation in English also. But if you see different types, RU and UK, you are UK. Sorry, not you are UK. For Ukrainian language, it's a type for Ukrainian language. You can see that this labeling is very difficult, and sometimes this mixing, it's really mix such a salad with different ingredients in one paragraph, in one sentence, and it's really difficult to identify what is the language you can find. Also, before you apply some methods for the language identification or sentiment analysis, you need to analyze your code switching corpus with different coefficient. The first coefficient is lexical overlap. It's a very easy, and I think it's not so bad, but it's a very general coefficient, but also can be used. And other methods other approaches is the code mixing index, M-index, and integration index. You can see also the formula of these indexes on this slide, and I try to describe why we need to use this. Yeah. So M-index is a multilingual index. It's the word counted-based measure that quantifies the inequality of the language tags distribution in a corpus of at least two languages. I need to mention that code switching, it's not only about two languages. It can be 2, 3, 4, and more languages. But usually people use two languages. So in this formula, key is the total number of languages, and P is the total number of words in the languages over the total number of words in the corpus. The value range between null and 1, where the value of null corresponds to a monolingual corpus, and 1 corresponds to a corpus with equal numbers of tokens from each language. So these coefficients help us to define our corpus is the code switching or not. The next integration index. Integration index is the approximately probability that any given token in the corpus is a switch point. Given a corpus composed of token targeted by language, where I range from 1 to n-1, the size of the corpus, and I index is computed as this formula, where s can be equal 1 or 0 for a corpus with n tokens, where are n-1 possible switch points. It quantifies the frequency of code switching in a corpus. And the last, it's also very popular metric, is a code mixing index. At the UTC level, there is compute by finding the most frequency language in the UTC and the counting the frequency of the words belong to all other languages presence. Yeah. Where sum is the sum over number of words and all n languages in the utterance. Max is the highest number of words present of any languages, and n is the total number of tokens, and u is the number of language independent tokens. So the range of for this coefficient is from 0 to 100. And if an utterance has language independent tokens or only monolingual token, that the corresponding CMI value is 0. A higher value of CMI index indicates a higher level of mixing between the languages. And CMI all is the average over all utterances in the corpus, and CMI mixed is the average over only code switches instances. On this slide, you can see examples for some data set for different languages, but the authors calculate similar indexes, and you can see the value for this index can be from the 3 to 50. And we understand that the last Magahi Hindi English corpus is very difficult. It's very code, so it's a really code switching corpus. For you need to understand, can you use this corpus for research or not? Yeah, before experiments. So some words about our data set. So we have, and now we have more than 20,000 Ukrainian words in, after labeling. Yeah, in our data, in our corpus, 30,000 Russian words. Hybridized words 225. In Ukraine, we also use for such words the name sushik. So it's this case when we combine two languages on the morphological level in one word. Other dialects, other languages, etc. 600, and punctuation. So in our experiments, we try to use we plan to use conditional random fields, maybe support vector machine, and other methods from the deep learning, BERT, or maybe MBERT, etc. and compare our result with other. Also, it's interesting when we found now, after labeling, we found some cases when, for example, we cannot identify our expert annotators cannot define this word Russian or Ukrainian without audio. So it's also, so we cannot define this word. And other case we have I don't know, maybe 3 or 4 words in Ukrainian, but the general structure of this phrase speaker took from the Russian. So it's so we cannot say that it's Ukrainian or it's Russian. It's a mix, but it's mixed not on the token level. It's a mix on phrase level, on syntactic level. I prepare some publication for you. Maybe it's interesting. The first publication about our code switching corpora of Ukrainian parliament. It's a publication with our first result. The second publication is a good overview about code switching research in NLP. You can find a lot of useful information. And the last, this publication about the Turkish German code switching tree bank. I think it's a very good first step to analyze such data and corpora from the syntactic structure and morphological structure. So thank you very much. Thank you for your attention. If you have some questions, I'm ready.